Good day, learners. Welcome to Technical Mathematics lesson. My name is Mathulela Takomu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Grade 11s, our topic of today is exponents and surds, but we're going to look at specifically on how to solve exponential equations. So if we're looking into our lesson objectives, it says at the end of this lesson, learners should be able to solve exponential equations when the base is unknown, and we also need to know how to solve exponential equations when the exponent is unknown. So those are the lesson objectives of today. So we're looking at now the basic rules of how to deal with this. We're looking at the first one. It says we're solving exponential equations with equal exponents, correct? So now, looking at that, we're saying when the exponents are equal, it means we don't know what it should be in the base, correct? So now it says if a to the exponent of x is equal to b to the exponent of x. Remember, the exponents of x indicating that the exponents are the same. It means the exponents are equal. Then if the exponents are the same, what you do is to equate the base. That's why we're saying then a is equal to b. Mind you that a, it can be any number, and also b, it can be any number, or a, it can be a variable, or b, it can be a number. So now let's look at the second one then, which says we solve exponential equations with the same basis now. So now we're looking at this one. We're saying if now the exponents are different but the base are the same. So what do we say here? If you have the same base, now we equate the exponent. It means now x is going to be equal to y. So now we're looking into the same exponents, we're equating the base, and we have the same base, now we're equating the exponent. We can see our example there. We're saying if you have 2 to the exponent of x, it's equal to 2 to the exponent of 3. So now we're saying the base are the same, then we equate the exponent. Therefore, x is equal to 3. And then now it says, when do we have the exponents? Remember, we call this thing a power, but now you must understand that the base is what is carrying the exponents, correct? So now, looking at activity number 1, remember all the time, you must know that we're dealing with this when we are solving for x. So the question states, solve for x in the following equations. Then we are having activity number 1, and we have 4 equations there. Then we need to solve for x. It means basically we must make x the subject of the formula. So in this case, what do we do now? We have x there to the exponent of 2 is equal to 25, correct? So now looking at this one, when we are using our basic rule of exponents, where we're looking into the same exponents for us to equate the bases, we know that we have x squared is equal to. Then if ever we're looking into our prime factors, if you look at the prime factors of 25, you are going to have 5 to the exponent of 2, correct? Then now you can realize that the base the exponents are the same, therefore you are going to equate the base. It means x is equal to 5. And then remember, here we are just applying the exponential laws, where we say if the exponents are the same, then you can equate the base. Knowing very well that when we're dealing with this in algebra, we will say if x it has it's x squared, it means we must have two solutions of x, of which is correct. Then if you want to solve it in the other way, one would have said, okay, if it's a square like this, I can either introduce the square root both sides, knowing very well that you are going to have x with two values of x, which is positive and negative. But if we want to test them in our equation there, they are going to give you positive 25, both of them. Hence, we're saying here we are applying the rule of exponential equations, where we say if the exponents are the same, we equate the base. So either of the two, it will be correct. Now, we move forward to the second activity. With the second activity now, we are having 2x to the exponent of 3 is equal to 54. Then we remember now we have to make sure that we have x as our subject of the formula. Then here there is a little bit of work that we need to do. We know that we have 2x cubed is equal to 54. Then we know that we need to divide both sides by 2. We divide both sides by 2. And we know that 2 will divide by 2, we have 1. Then we're going to have x cubed. It's equal to, if you say it when 54 divided by 2, we have 27. Now, we have to now solve for x. We can now look into the prime factors of 27, which is going to be 3 to the exponent of 3. And now we can see that our exponents now are the same. Therefore, we can equate what? We can equate the base. It means x is equal to 3. So this is how you solve this particular equation. Then, when you move forward to the third one, you must realize that there are two ways of solving this type of the equation. We now need to go back to our laws of exponents to say if you have an exponent of a negative number, we can change it to a positive number by writing it as 1 over a to the power of n. That is the basic rule that we are going to apply here. So in this basic rule that we are going to apply here, we can start by now changing this one to saying I am having 1 all over x to the power of positive 3. It's equal to 1 all over. Now we can write 125 in prime factors, or we can still write it as 125 because we want to simplify that first. Then we do what? We cross multiply. As we cross multiply, we are going to have x cubed is equal to 125. Sorry about that. Then now we're going to have x cubed is equal to. Then we now get the prime factors of 125 is going to be 5 to the power of 3, or to the exponent of 3. Then now we can see that also on this one that the exponents are the same. The exponents are the same. And when the exponents are the same, we can now therefore say x is equal to 5, because when the exponents are the same, we equate their base. So that's another way of dealing with it. Remember, we have different learners and they think differently. Some learners can approach this in this manner, to saying x to the exponent of -3, and they say now here we have 1 to the power of 5, 1 divided by 5 to the exponent of 3. Then now we have x to the exponent of -3 is equal to. Now we apply our rule. Remember, we can now move from this side to that side. And they can write this one as 5 to the exponent of -3. And looking into those exponents, they are now both negative. Therefore, x is going to be equal to 5. You can see that you can approach in two different ways, but at the end of the day, the answer is going to be the same. Hence, we say we have so many ways to deal with this type of an equation. So whichever way you understand it, then we use that particular method, as long as your answer is going to be correct and the steps, they are mathematically correct. So we're looking into now the last one. Now looking at the last one, we can see that is the same as the second one. We need to now firstly rewrite this equation. We rewrite our equation. We are having 243. Then we are going to divide both sides by 3. So now we know that 3 divided by 3, you will have 1. Then x to the exponent of 4 is equal to. So if you say 243 divided by 3, you are going to get 81. You are going to get 81. Then now, the prime factor of 81, is going to be x to the exponent of 4 is equal to 3 to the exponent of 4. So therefore, you know that you are having the same base, the same exponent, the same exponent. Then your x, it will be 3. Then you say 3 to the power, 3 to the exponent of 4 is 81. And another thing that you must understand about this is to say, whenever you arrive at your answer, you can still check your answer. How do you check your answer? You know that the value of x is equivalent to 3. Then where you see x on the right left-hand side, we substitute 3. You can still write it as x into 3 to the exponent of 4. Then if you put that inside the calculator, you will see that it amounts to 243. It amounts to 243. So you can see that this side we have 243 when we substitute x. So this is how you can get marks when you are dealing especially with solve for x. The minute you are done solving for x, you can still check your answer if the variable or the roots that you got there, they are correct. So we move forward now to activity number 2. In activity number 2, you can see that it's different from activity number 1, because looking at activity number 1, you can see that now on the base, we had the unknown variable. Now we're looking at the activity number 2. You can see that the unknown variables now, they are in the exponents. So we have the exponents of the unknown variables. So now we look into the rules of exponents and we deal with this one. So now we're looking at this now. Our aim is to make sure that we have the same basis. So we have to understand now the rule of prime factors. So I will have 2 to the exponent of negative x, 2 to the exponent of negative x is equal to, now we go and have 64 as a prime factor. If you have 64 as a prime factor, you are going to have 2 to the exponent of 6. Then you can see that in this case, we have the same base. And we have the same base. When you have the same base, what do? You will equate the exponent. We are going to have negative x, it's equal to 6. Remember, we have the same base, we equate the exponent. Then here we have negative x, and we are looking for positive x. Then we need to get rid of that negative 1 by now dividing both sides by negative 1. So now, your negative divided by negative, we know that is positive. Then x, it will be 6 divided by negative 1 is negative 6. Then that's how we solve that particular equation. Then, like I said, that you can still check it if you are correct. Then how do we check it? We have 2 to the exponent of negative into. Now we substitute what? We substitute negative 6. Then as we substitute negative 6 there, you will see that you'll have 2 to the exponent of 6. It's equal to 64. Not 24, sorry. Not 24, but we are not at 24, but we are at 64. We are at 64. Correct? We are at 64. So this is how you can check your answers. Then we now go to the second one. With the second one, it looks a little bit tricky, but it's not that tricky. It's as simple as ABC. What you need to know that is to say, you need to take and get the prime factors of 9 and also get the prime factors of 27. So the prime factors of 9, we know that is going to be 3 to the exponent of 2, and we still have 2x there. Then with 27, we will have 3 to the exponent of 3, then we have 2x minus 1. So how do we then deal with this one? We are going to apply our basic rule of exponents where you had, let's say, a to the exponent of n, and you have also the exponent of n. Then you are going to say this is a to the exponent of n multiplied by the exponent of m. That is the basic rule of exponents when you're dealing with such brackets. Then what will happen here is that we're going to multiply 2 by 2x, and then you multiply 3 by 2x and 3 by negative 1. That's what you are going to multiply. So as we move forward, we're going to have 3 to the exponent of 4x, it's equal to 3 to the exponent of 6x minus 3. 3 multiplied by 2x is 6x, and 3 multiplied by negative 1 is negative 3. Now that the bases are the same, we are going to equate the exponent, which is 4x, it's equal to 6x minus 3. Then now, we have to solve for x. Remember, the base were the same, then we equated the exponents. Correct? And the exponent on the left-hand side is 4x, and the exponent on the right-hand side is 6x minus 3. Now we have to make x the subject of the formula, you know that we are going to look into our mathematical operations and we transpose that 6 to the left hand side. So we are basically going to have 4x minus 6x is equal to negative 3. Remember 6 was positive on the right hand side. As we transpose, it changed the sign to negative. So we are going to say 4 minus 3, we are going to, 4 minus 6, we are going to have negative 2x. It's equal to negative 3. Then we are going to now divide by negative 2 because we are getting rid of negative 2. Negative 2 divided by negative 2, therefore your x is going to be 3 over 2. So that's how we are going to solve that particular question. So you can see that the first step, I had to make sure that we have the prime factors of 9 and 27 because our aim is to make the base the same. So we're looking into this type of a question. Most of us, we are going to look into it, and then now we start worrying when we see decimal numbers there. But with this type of a question, what you need to know is that you can still change that decimal number and you write it in a fraction. You're basically going to punch it in a calculator, and you have 0,001, and as you punch it in a calculator, you are going to have 10 to the exponent of x, 3x minus 2, it's equal to 1 all over. Then you will see that there we have 10,000. Correct? Then now, when you get the prime factors of 10,000, when you get the prime factors of 10,000, but we write it in a base of 10, you will see that you will have 10 to the exponent of 3x minus 2, it's equal to. Now, if you say 10 to the 4, 10 to the exponent of 4, 10 to the exponent of 4, you are getting 10,000. But in this case, it has 1 there at the top. Correct? Then now we need to make it a negative exponent because 10 should be at the base. You still rewrite 10 to the exponent of 3x minus 2, it's equal to now 10 to the negative 4. Then now your base are the same. Your base are the same. And when your base are the same, what we do, we equate the exponent, which is going to be 3x minus 2, it's equal to minus 4. Then you transpose your negative 2 to the left hand side, to the right hand side. We're going to have 3x is equal to negative 4 plus 2. Then 3x is equal to negative 2. Then you are going to divide both sides by negative 3. Then 3 divided by 3, x is equal to negative 2 over 3. Then that's how we get that particular question. So now, you don't have to be worried when you see the decimal numbers. You can easily use your calculator to get them into proper fraction. Okay? Then now, we're looking at the next one. We always need to understand our exponential rules for us to be able to solve this type of questions. So now we are having number 4, which is 1 over 2 to the exponent of 2x minus 4, multiply by 64 to the exponent of 2x plus 1, it's equal to 8. So now, going back to the basic rule of exponents, remember, if you have a number written like that, you will know that that number is always carrying the ghost 1. Correct? So we can see that our 2 there, it always carries the ghost 1 there at the denominator. So writing this in the base of 2, I will know that I will have 2 to the exponent of negative 1 multiplied by 2x minus 4 multiplied by, now with 64, the prime factor of 64, I know that is 2 to the 6. Then we have 2x plus 1 as the exponent, which is equal to 8. We can also write it as a prime factor, which is 2 to the exponent of 3. So the aim here, remember, is to make the base the same. But in this case, what we need to do is to now remove our brackets. Then as we remove our brackets, we are going to have the following. 2, if you say negative 1 multiplied by 2x, we're going to have negative 2x. And then negative 1 multiplied by negative 4 is positive 4. Multiplied by 2 to the power of 12x plus 6, because this 6 will multiply 2x and multiply 1, and this will be 2 to the exponent of 3. Then now we still go back to our basic where we're saying if you have the same base that are multiplying each other, you are going to do what? You are going to add the exponents. So now we have 2 multiplied by 2, which are the base are the same. Then we're going to have 2 negative 2x plus 4 plus 12x plus 6. It's equal to the exponent of 3. So remember here we applied the rule of the same base, we add the exponents. And we look into the like terms, those are the like terms, and then also the constant numbers are there. So now, what do we do now? We're going to have 2. If you say minus 2 plus 12x, we are going to have 10x. And then 6 plus 4 is going to be 10. It's equal to 2 to the exponent of 3. Now, in this case, you realize that, okay, I'm having the same base. We can equate now the exponent, which is 10x plus 10. It's equal to 2 to the exponent of 3. Sorry. We no longer write the base because we said the base are the same. Then we equate the exponent, which is 3 then. Then you take this 10, you transpose it. We are going to have 10x, it's equal to negative 7. Because if you say 3 minus 10 is going to be minus negative 7. Then we divide both sides by 10. 10 will divide 10. Therefore, x is equal to negative 7 over 10. So now that's what we are going to get there as our value of x. Remember, you need to take things step by step. Okay? Now, that is activity number 2. We move to activity number 3. You can see that as we move to activity number 3, it gets a little bit complex, But we also need to understand the definitions of exponents. We also need to understand what we call definitions of exponents. Let's remind ourselves of some of the definitions of exponents. We know that any number raised to the exponent of 0, that number, it will be equal to 1. Remember, it can be either a number or a variable. It doesn't matter. It can be a number or a variable. It doesn't matter. But what you need to know is that you need to know and understand that any variable or any number raised to the power of 0 is equal to 1. Now, when you are given 1, it can be equivalent to any number raised to the power of 0. We can test, we can say 10 to the exponent of 0, you get 1. 100 to the exponent of 0, you get 1. So it can be any other variable. X to the power of 0, it's 1. A to the power of 0, it's 1. That's how the rule works. So now we're moving from 1 and we raised any number to the power of 0. Looking at the activity there, we have to solve for x, and the first one, it says 100 to the exponent of x squared minus 3x minus 4 is equal to 1. Remember here, our aim is to make the base the same. And how do we make the base the same here? We can see that on the left-hand side, the base is 100. And we agree that if I can write this 100 to the exponent of 0, it's equal to 1. So that's what we're going to do. Why are we choosing 100? Because the base on the left-hand side is 100. So we are going to say 100 to the exponent of x squared minus 3x minus 4, it's equal to, instead of writing 1, I can write 100 to the exponent of 0. So now that the base are the same, we can equate the exponent. It means it's going to be x squared minus 3x minus 4 is equal to 0. Then you can see that we have a quadratic equation. Remember, you can either factorize or use quadratic formula. So with this one, we can easily factorize. So as we factorize now, I always tell learners that the minute you see that the last term, it has the negative sign. The last term has a negative sign. It means inside the bracket, there is no way that you're going to have either two positive signs or two negative signs. If the last number or the last term has a negative sign, you know that inside the bracket you must have two different signs. Then we can start factorizing there. We know that we factorize, and in that we have two different signs. So we're now looking into the last term. Now we're talking about numbers. We're saying the factors of 4, that when you multiply they give you 4, and when you subtract or add them they give you 3. The numbers that when you multiply they give you 4 and you subtract or add them they give you 3. You will know that is 4 and 1. Those are the two numbers. But now, when you're looking at 4 and 1, the middle sign is negative. It means the bigger number will take the sign of the middle term, which is 4 and 1. And that's how basically you factorize. That's how basically you factorize. Then now we apply what we call zero factor rule. Zero factor rule, it says, if you are having the product of two brackets, you can simply equate each bracket to 0 because we have 0 on the right hand side. Then in this case, we will simply solve for x. We make x the subject of the formula by transposing positive 1 and negative 4. So we're going to have negative 1 and x as 4. So that is the basic of how you can solve the exponential equations. Remember, it started as an exponential equation. We dealt with the exponential part. Then we now moved to the quadratic equation. Then now we need to now apply the method of factorization, or we could have used the quadratic formula. Either of the two, it works better. Let's move now to the second one. We move to the second exercise there. You realize that on the left hand side, we have an expression that we need to simplify. Correct? Now, on the right hand side, you can realize that we are having 1. And looking at the left hand side, we can see that all the bases there, they are raised to the base of, the bases are 3. Correct? So now we know that if we have 3 to the exponent of 0, we are going to get 1. So that's how we can change that one to 3 to the exponent of 0. Before we do that, let's deal with multiplication of the same base and division of the same base. So if I look into the numerator, I will have 3x plus 2 plus, because I'm multiplying the same base, I'm going to say 2x, all divided by 3 to the negative x squared is equal to 3 to the 0. Remember, we said we can change it to that. Then you are going to have 3 to the exponent of 3x plus 2, all divided by 3 to the exponent of negative x squared. It's equal to 3 to the 0. Then now we're looking into division of the same base. So we are going to say 3 to the 3x plus 2. We subtract, and we also subtract by what? By x squared, which is going to be 3 to the 0. Now, why do I put the negative here? Remember, this negative here is the negative for division of the same base. And the negative that you see there is the negative of the number, the exponent there. Then we are going to have 3. When we multiply here, we're going to have x squared, and we can write it now in the standard form, which is x squared plus 3x plus 2 is equal to 3 to the exponent of 0. Then now we can see that the bases are the same. We equate now the exponents. We're going to have x squared plus 3x plus 2 is equal to 0. Then now we can start factorizing there. We know that we're having x and we're having x. In terms of decision of signs, we can see that the last sign there is positive and the middle sign is also positive. It means inside the bracket I will have 2 positive signs. Then with numbers now, the factors that you multiply, the numbers that you multiply, they give you 2, and then you add, they give you 3, is basically 1 and 2. Then 0 factor rule, x is equal to x plus 1 is equal to 0, or x plus 2 is equal to 0. Then x will be negative 1. X will be negative 1, or x will be negative 2. So that's how you are going to solve this particular question on exponents. You can see that now we're learning about expressions that we have learned on the previous weeks. Now we apply that method of simplifying the expressions before we can get to the rule that we use of the same base and equating the exponents. So you must understand all those rules of exponents. Now we're looking at the third one. Looking at the third one now, you can see that we are having an equation where we have to simplify the left-hand side. And how do we simplify the left-hand side? We can see that on the left-hand side we have two terms. It's 2 to the exponent of x plus 3 multiplied by 2 to the exponent of x. It's equal to 16. We can see that here we have what we call a common factor. We have what you call a common factor. And if you take out the common factor here, remember, taking out the common factor is like dividing by what is common. We divide by what is common. So if you have 2x plus 3 multiplied by 2 to the exponent of x, by taking out the common factor, it means I will divide everything by the same factor. Then you know that if you divide this one, you get 1, plus if you divide this one, you remain with 3. So basically, that's what you are going to have as we're taking out the common factor. Inside the bracket is 1 plus 3. It's equal to 16. Correct? Here, remember, we still have the exponent of x. Then we are going to have 2 to the exponent of x. 1 plus 3 is 4. Then we also have what here? 16. Then we can divide both sides by 4. As we divide both sides by 4, 4 divided by 4, it's 1, which is going to be 2 to the exponent of x. It's equal to, if you say 16 divided by 4, you get 4. Now, when we move forward, we are going to say 2 to the exponent of x, it's equal to 2 to the exponent of 2. Remember, we can write our 4 as a prime factor. Then, you will say now the bases are the same. We're now equating the exponent. X is equal to 2. So this is basically how you need to solve this. And also remember that on the previous weeks, we spoke about the simplification of terms. Correct? We now move forward to number 4. We are having x to the exponent of x plus 1 and minus x to the exponent of x minus 1 is equal to, minus 24 is equal to 0. We take negative 24, we transpose it, and then now we work with separation. Remember, there was a lesson where we dealt with separation. We saying if you were to multiply the same base, we're gonna add those exponents, correct? Then that's how we're gonna separate it. So we're gonna have 3x multiplied by 3 to the 1 minus 3 to the x multiplied by, multiplied by 3 to the negative 1. It's equal to 24. So we apply the very same method of taking out the common factor. Then in this case, when you take out the common factor, you're going to have 3 to the exponent of x into 3 to the exponent of 1 minus 3 to the exponent of negative 1. It's equal to 24. So we're going to have 3 to the exponent of x. And if you say 3 minus 3 to the exponent of negative 1, we are going to get 8 over 3. Then it's equal to 24. Then now we get rid of 8 over 23. It means we are going to divide both sides by 8 over 3, and also this side we divide by 8 over 3. Then we are going to cancel the 2, cancel out. Then we're going to have x to the 3 to the exponent of x is equal to. If you say 24 divided by 8 divided by 3, you are going to get 9. Then we know that is going to be 3 to the exponent of x. It's equal to 3 to the exponent of 2. The bases are the same. Therefore, x is equal to 2. So that's how we solve this particular questions on exponents. Correct? And this now is the end of the lesson. I hope you have learned a lot on how to solve exponents and exponential equations, when you have the same exponents, you're equating the base, and when we have the same base, you're equating the exponents. So thank you.